transform using the transform of integral. Now let's look at the formula of the transform of integral. That is inverse Laplace transform. The fs over s should be equal to 0 integral 0 to t f tau d tau. So this is the formula. Okay, now let's look at the example. Solve using the transform of integrals. So you have inverse Laplace transform of 2 over s squared plus s. Okay, first of all, if you look at this s squared plus s, we can factor out the s, so we can get the s plus 1, right? Okay, now if you want to use the transform integral, the format should be the same. What do you mean here is the format here, you must fulfill the format here, only you can use this equation. Okay, now let's do it together. You compare with the inverse Laplace transform of the fs over s. Okay, can you see something similar? Okay, this one is this. Okay, that means your fs is 2 over s plus 1. Okay, so what is the inverse Laplace transform of the fs? So this will be 2 inverse 1 over s plus 1. Okay, so what is the answer for the inverse Laplace transform of fs? That should be this one from the table. This one you give the shifting is exponent negative t. So you have the 2 here, so 2 exponent negative t for the inverse Laplace transform of fs. Now you have another part, that is inverse Laplace transform of 2 over s plus 1. Okay, so this one will equivalent to, since we have the same format, so we can use this equation. So it's the integration 0 to t, okay, f tau d tau, means the f tau is the fs here lah. Okay, so is 2 exponent negative t dt. Okay, so you integrate it, so you get 2 exponent negative t divided by negative 1. Okay, and the limit is 0 to t, and end up you will get negative 2. You substitute the t with t, and another one is 0. So it's minus, so it's plus 2 lah, because exponent 0 is 1. So you have a negative, positive, negative, positive, so I have positive 2. Okay. Okay. If you want to solve, this one is solved using the transform of integral by fulfilling the format of the transform integral format. So we can use the equation, the integration of 0 to t f tau d tau. Let's say if you want to solve using partial fraction expansion, that should be no problem also. Okay, so let's say if you use the same question, 2 over s squared plus 2. So you can solve like 2 over s plus 1. Then you can change to a over s plus b s plus 1. Okay, so now you have 2 equivalent to a, you times up, so you have s plus 1 plus bs. So you assume the s equal to 0, what do you obtain? When s equal to 0, you have 2 equal to 8. Okay, what if you assume s equal to negative 1? So you have 2 equal to 8, negative 1 plus 1, so you get 0, and then means that you have a negative b here. So b is equal to negative 2. Alright, so you can substitute back. So the inverse Laplace transform 2 over s squared plus s equal to, so a is 2 over s, okay, minus with b is negative 2 s plus 1. So if you solve this inverse Laplace transform, you can get the 2 1 over s plus 1. So you can obtain this one is 1, so you have 2 here, minus this one 1 over s plus 1. Okay, it's a exponent negative t, so you have negative 2 s for negative t. That's all. So it means that you can solve using the transform integral, or you can solve using partial fraction expansion. Okay, let's try another example using the transform of integral. Okay, if you have this kind of question, okay, how to solve this? Again, you need to factorize it out, means that you factor out the s. Okay, factor out the s, and then okay, this one already factor out the s. You have the x squared plus 4. Okay, 1 over x squared plus 4. What is the Laplace transform for, let's say you have a x squared plus something? So it should be about sine. Okay, so do you still remember what is the sine? So your sine at is a over s squared plus a squared, right? Okay, so we have the a is about 2. Okay, 2 power of 2 is 4, so a is 2. So we can rewrite. So this one is 2 over s squared plus 2 squared. Okay, this one is this one, and then you have the s here. You have the s here. The s here actually is to fulfill the format of transform of integral. And then don't forget you have the 2 here, means that this is the extra, so we need to cancel out by time the 1 over 2. So this one will be equivalent to, since we have the same format, we can use the formula 0 to t, and then we know that this part is the sine, so it's a sine 2t dt. Okay, and then the integral of the sine you obtain negative cos. Okay, negative cos 2t over 2, and then the limit is from 0 to t. Then substitute the t with t and then followed by 0. Okay, you have a negative and with minus, so it's a positive. And then you can solve the problem. You simplify and you solve it. So this one you get 1. So you have cos negative 2t over 2 plus 1 over 2. So you obtain 1 over 4, 1 minus cos 2t. Okay, that's all for this question. Thank you for watching how you can understand what is the transform of integral.